Okay, hi everyone. Welcome to another Wolfram language design review, part of our incremental language design series. And we have a variety of topics. Let us start with the same as and replace at documentation. Okay, let's see.
These are two different functions that came out of Wolfram function repository functions we looked at previously. They both have implementations and prototype builds, and we just wanted to finalize and make sure everything looks good here. Oh,
yeah.
Yep.
Well, does the implementation of replace that address my concerns about the extended syntax?
Yeah, so we have the same syntax support in replace at that we added into map at in terms of the handling of multiple positions was the question, I'm guessing.
Right.
SameAs has the bizarre feature that it is subcommutative, so to speak, for what it's worth. So what? Yeah, I think this is okay. That's interesting. Same queue. What does that mean? Wait a minute. Why is that right?
Why is what right?
This multi thing here.
I mean, same queue is varargs. What else would you expect same as to do?
Yeah. I mean, the only possible point of disagreement is maybe the y's should come before the x's in the same queue. But other than that, I don't see how there's anything controversial here.
Is there any time when the order matters? Like, does it, I guess maybe for some performance things, it could theoretically matter, but not actually.
It can, I think it can matter if you have, arbitrary precision, well, at least machine precision, if you have inexact numbers, because like the bits might be close enough that they're sort of all close to each other, but like the last one is not, sufficiently close to the first. But
I see. So it only does pairwise checking when you give it varargs things.
Right.
I see.
I personally have no problem with the second bracket. The first bracket feels a bit strange because you could know that it's going to return false always without the second bracket. And I can imagine that this is not going to be converted into false function.
Right. Right.
Right. As it currently stands, there is no down code associated with same as.
Right. Even though, as Jose says,
right, same as X, Y applied to anything will be false.
But now, if the idea of that is that it's sort of a bit of a performance thing, then it just means it's going to have to run same queue on the X's twice. Once in the down code, once in the subcode.
Right.
Yes.
I mean, we could. Right. I mean, we could. Yeah, I don't think there's a good way to do this. I mean, I suppose you could make the argument that same as bracket could evaluate the same queue, because that really is.
I think my argument is that the first bracket should have just one element, and the second any number.
I kind of agree.
I see.
I kind of agree. And by the way, I don't understand what this line means.
Right. It means it means what I just said. So same as of the bracket, now open bracket XY is equivalent to bracket of XY. Now, if we're going to say that same as can only ever be one argument, and that same as of bracket should be an error message, and same as of two more guys should be an error message, then I'm okay with that. I guess what did we do with equal to? I guess that's the question. So what does equal to of bracket do?
Yeah, Equal to does require one argument.
Okay.
Equal
Seems like that would be a
args,
good
though?
place to be.
Say again?
Equal
Right.
is
So
with
what does
var
that
args, right?
evaluate to? To itself with the message. Okay. Right. And does equal to of one bracket, 2, 3 work? So even though it's documented as, ooh, well, that's a very
Yeah,
unfortunate
that's a little
behavior.
Suspicious.
This could be extended.
Right.
The second one.
Yes. Right. I mean, right. I mean, to me, right. I think that in the second set of brackets, it should be var arg, just like equal is. But I think I take no position on whether the first set of brackets should be var arg or not, and I'm perfectly okay with it being restricted to one argument.
I think that's the defensive design that we should adopt right now.
Okay. Yeah, I can probably make the changes to equal to have var args in the second set
Okay.
of brackets, but we'll use that as the template for same as then.
Okay, replace that. Oh boy, this looks more complicated. What is
So I
replace
forget,
that?
last time, what was the difference between replace at and map at of replace?
That replace at doesn't depend on evaluation.
I see.
Right. So replace
So you
at
can
is
replace that inside of a hold, and it'll actually do the replacement as opposed to just inserting a replace operator form.
right. On a certain level, if we had the immediate evaluate we've talked about, we wouldn't really need replace at other than possibly a syntactic sugar.
Replace that seems useful. I mean, I see. So we can have a span here as well, presumably. And a
Yeah.
span means
Yeah.
take each individual place. So if I say,
Right. So the way we dealt with this on extract, right, is we basically said, there you have position specs and then you have extended position specs, which are basically a part spec wrapped in a list. I mean, you can look at the notes for extract if you want to see exactly how we stated that there. Right, an individual position specification pause can also be of the more general form list part 1. So the third note there.
okay, this is useful. This part, replace that. Okay. Anything more to discuss about it?
Nope, I think that one in particular is in good shape. We'll make the changes to same as and equal to.
Okay.
The next point was just we had a discussion about AncestorTree and Treetop in a previous meeting and wanted to circle back to the names and just make sure we were all on the same page there.
I don't like AncestorTree. I mean, I'm not even sure I like either of these. Let's just discuss what they are again. Here, can I by the way, why is there that delay? on first use. Is that a loading thing?
I think so.
Is that,
I think it's auto-loading.
is Ian here?
Yeah.
Okay. Can you say what that delay is?
I'm assuming Jose's right.
Can we look at
when you scroll down in the graphic, and before it shows the graphic, it stops a second.
say that again?
You're just talking about the delay of when you scroll down and before it shows you the graphic of the tree, it pauses a moment.
No. I'm talking about the fact when I typed round tree at 30, it took a while.
Oh,
Whereas if I try it again, I'm sure it's blindingly fast. Yeah. So my only point is, can we at least look at the loading to just see if there's anything we can optimize there?
Okay.
Is it being loaded in any way differently from other MX files?
Shouldn't be. It's a pure. It's now a pure startup thing. I mean, it does depend on some number of things, right? So
Right.
it may be auto-loading more than one MX file, which is
Why don't we
probably
investigate it? Okay. Is this not yet in there? AncestorTree and treetop.
Correct. Treetop, I have a branch open, but it's not in the prototype build.
and there hasn't been a prototype.
There's so many
built in 2
jokes about
days.
branches and trees.
Yeah. Unfortunate for I've opened an RE ticket why there hasn't been a new prototype built since Tuesday. So they're looking at that now. So even if you had added it, it wouldn't be in in Stephen's build yet.
Okay. All right.
It's fate.
Gives the top of the tree. You don't want to say up to level N. You need to say down to level N. If it's the top of the tree, or just to level N, it's totally
Right.
confusing.
Level N.
Well, there's a breakdown in terminology also because normally the top of the tree is where all the leaves are. But this gives the trunk, right?
Right. It's really like tree roots or tree trunk.
So
I guess.
the reason that we had up to was because it has up to like behavior.
Okay, look.
That's not a good reason in
Mhm.
this case.
Okay, what should we call this? So let's see what it does again.
Tree shrub.
And tree take is already taken for something else.
No,
It's not taken.
correct.
Right. Although
The notion of tree roots are that's a pretty common notion and terminology in computer science. Probably should not reverse it or anything.
Well, but isn't the roots is like the root is the single top one? Is there a name for like the intermediate ones where it's not a leaf and it's not the root?
Sometimes the term node is used both for intermediate and atoms.
What about calling it root tree?
What? So I guess the thing is the operation is going up to a level. And the name isn't communicating anything about that. We're just saying that
what about
giving the result is a tree and trees have a root.
Right.
I understand, but what about
It's just a complete coincidence.
wait a minute, what about calling it a root tree?
that every tree has roots and or has a root. Like
I know
think
that. But that's just the tree, it's just the root part of the tree.
But the root part of the tree is the single vertex at the top.
I know, that's why it's called a root tree rather than just the root.
Are you thinking about it as like this
right?
This upper part of the tree is like a root, and then there's
by upper. No, we're talking about this is the tree root. We all agree that's the tree root.
Yes,
right.
Even though botanically it's at the top.
Right. So we're making the distinction between tree root and root tree.
I'm starting to like Itai's idea of a trunk because that's what we're capturing.
It's not the trunk. It's not the trunk. It's the part of the tree. It is the root tree. It is the part of the tree hanging from the root that only goes to a certain level.
I mean, other than the fact that if we had something called tree take, we'd need to also make some sense of negative and spans.
Well, negative works.
You get disconnected.
I don't think spans is
that
meaningful.
way. You're going to get disconnected subtrees if you go from the top.
No, so negative just means go down to the negative level. You're still always going from the top.
Oh, well, then we definitely don't want to, I don't think we want to call that take, right?
Yeah.
No.
It doesn't take a take spec, so.
You know, I'm sorry. I keep on pushing root tree because I think it's a pretty good name. It's the tree. It's the root section of this tree.
I think that the problem is that root just, root is just has a very strong and particular meaning, and the connection to this concept is extremely tenuous.
But root tree, comma 1, but it isn't just the root. It's the, I mean, okay, let's look at what ancestor.
Can I just say, if you do comma infinity, it's just the whole tree. Like
I know.
What you're describing, it's from the root down. That's just describing a tree.
I know. It's just all good. Let me understand what AncestorTree is. Okay, just so I understand what. That's the AncestorTree of a given node. Is that
It's
right?
the same thing, but with a position
expect-
spec instead of a level.
I was expecting things like, second cousin once removed in AncestorTree, and I don't see
Yeah.
that.
That will be supported symbolically in the tree relative.
Okay, I don't understand AncestorTree. So you're saying in one case it's down to a certain level. In the other case, it is everything that you need that is in the the nodes that had to exist to get to this node. Is that correct? I mean, does it
To a
include
position or list of positions?
Yeah. So if you give a single
Same
position, it
operation.
basically just gives you a path tree that tells you how to get to the root, which is algorithmically, I think, super useful. Like if you imagine,
so it's like the minimal DAG, right?
Yeah.
If we were going to be technical, right? It's the minimal DAG that includes the specified elements.
yes?
Hey, what about initial tree?
I like it.
For what?
For what's currently
What you're
called
calling
treetop.
root tree or treetop?
I don't know. I don't buy that because it's the notion of time is yet a different issue.
Maybe it's a little too botanical, but we're also thinking about what we're doing to pull the tree back. We're effectively pruning the tree.
Oh,
pruning
for
has a
God's
different.
sake.
Yeah.
Yes, entertaining but not appropriate.
Well, that's a problem with AncestorTree. Is it's in the tree extract, tree delete family. That's usually tree action.
I suggested initial tree because the notion of an initial segment is also common in computer science.
Yeah, but I understand.
Right.
I don't
and-
understand why you guys so hate root tree.
I don't actually hate it. I just think it might not be optimal.
Okay, but I mean, what I like about it is that it is. Well, okay, I'm sorry. I still want to get back to this AncestorTree thing. Because really, we've got to have these two cases. One is you are finding the predecessor tree of a given node. And the other is you're finding up to a certain level down the tree. Right? Those are the two cases, as I understand it. Yes?
Yep. And I would say I'm definitely not in the camp that hates root tree, but I don't disregard the concern that it sounds too similar, that it evokes the root of the tree, which is a singular node.
I know, but root tree, comma 1 is the singular node.
Right.
No, comma 0.
Okay. I mean, root tree with one argument could be
Is there a one
Just as
argument
tree
form?
extract of a tree, comma 1 or 0 or something is the root. I mean, so what?
The root node is the empty list for a position spec.
Remind me what tree level does.
Sure.
It gives a list of the subtrees on the given levels. Same as level.
Okay. If we use root tree for the thing that goes from the root to a given level, what about the possibility of root tree and predecessor tree? Predecessor tree for ancestor tree.
Well,
It's
you
kind
know,
of-
I think
coming
ancestor is clearer than predecessor.
really, I was going to go in the other way, but maybe that's, you know, working on gravity. You know, coming from the Grouch school.
Well, okay, but ancestor tree, the problem is we got so much confusion with genealogical trees, which are different from these.
Well, no, so in a genealogical tree, it's actually a DAG, but in order to have the family relationships, you're referring to a tree within that DAG.
Yeah.
So tree relative is exactly the story of genealogical relationships.
Kind of depends on the type of family. I wouldn't assume it's always a tree. Just saying.
Well, so if you include everybody, it's definitely not a tree. And so you always have to choose a subtree of the DAG in order to speak about family relationships.
There is, however, a partial order for our species.
Yes.
The begat word works. Okay. All right. So what are we going to do here? So we've got one case is making the pruned subtree that just gets to a given particular position or collection of, or the union tree of those positions. And we've got another case that just goes to a certain level. Level tree. That's horrifying. Is it? Is it horrifying? Because that's what it is. It's a tree down to a certain level.
Say that again.
It's
Level
not
tree.
horrifying, no.
What's that?
It's not horrifying.
I like it
I mean,
more.
it's a
than
bit
root
annoying
tree.
that there's tree level and level tree then.
Yeah.
That would be genuinely confusing, so that's a problem.
Well, but don't they do complementary things, right? Level, what is it? The existing one, tree level, gives you everything below level whatever, and level tree gives you everything above level whatever.
Yeah.
No, people would not remember that. It's like having random sample and random choice, only worse.
No, I mean, yes, I mean, it's right. They are very related, but I agree that it's just like the ordering of the words means nothing. It's just arbitrary.
Okay. How about? I mean, how about admitting that they're the same thing, and basically trying to have two names that are, you know, one is level above, one is level below, or something.
Well, I don't think they're really the same thing, right? Tree level gives you a list of subtrees at that start at that level and go down to the leaves.
Yes.
Right. So, and you can give a range of specs, right? So if you give 3 to 5, right, you'll get a tree that starts with 7 or 15, however it is that we count, and goes down, and then, you know, a tree that starts at 24, and a tree that starts at 3, and a tree that starts at 9, and I know, right?
Right,
One always gives you 1, and the other gives you the number of nodes that live at that level. So it's not clear to me that they really are the same thing or complementary things.
Right. Whereas I think AncestorTree and tree extract are more genuinely like dual to each other.
What does tree extract do again? It makes the subtree from a given element.
Each position, you get a subtree.
You basically tell it if you start at the root and then you tell it go left, now go right, now go left, now go right. What do you get?
Yeah, as a subtree going on from there.
Yep.
Yeah.
And this is what you get getting to
How you
there.
got there.
Right. What the heck should that be called?
And I think the most common use is going to be something like, imagine you've implemented Dijkstra's algorithm and you have a tree of, the things that you hit, and now you want to, and you reach your destination.
Yeah.
Now you want to know how to take to get here, and you want to look at all of your ancestors.
Or it's a theorem proving-ish thing where you've enumerated all these cases and you want to know what the path was. What's the proof?
Sure.
Would origin tree be too generic?
Past light cone tree.
So it always goes all the way to the root, though, right?
Right.
Yeah.
It doesn't need to. Why would it need to? Why wouldn't it be able to go from level such and such to? Well, why could you not?
In that case,
mix
it could
and
give a
match?
list, I guess.
What is
I mean-
tree level? Tree level is of a level.
It's like
spec.
level only for trees, right? I mean, it really is. Right, just like level gives you this.
Wait a minute. Wait a minute. Tree level doesn't extract the tree. It's tree extract, comma tree level, right?
You can do tree level of tree, comma level spec. Same as level.
Oh God.
Right. Tree level is just, tree level of expression tree of blah should do basically the same exact thing as level of blah.
Yes. But the one argument form of a pure level spec, which occurs here.
Yeah, you can use these operator forms in position specs.
So why?
Sorry.
Go ahead.
No, on that origin tree, I was wondering, what about tree to node or something like that?
Do we call them nodes?
In various places, we've called them nodes. Usually when we want to convey like just this one position and nothing connected to it, like the node in the graph.
And what about the relation with tree delete? Because in tree delete, you also specify a number of positions and you delete what is from that position. Well, here you keep up to that position. So there is a difference in the node you are specifying plus the branches that you are not specifying.
Mm-hmm.
So could this be considered a variant of tree delete?
I think so.
What's a variant of tree delete?
AncestorTree, like going back to Nick's suggestion of tree prune, it's like tree delete, except tree delete deletes downwards.
This is
And
super confusing.
this is like
yeah, I understand.
delete everything other than what I specified.
What do we call the nodes here? Do we have a name for them?
Tree element or nodes.
Tree to element? No, that sounds like it's converting.
Well, the other problem is that sometimes element sort of sounds like atom, like you're at the very end of the tree.
Mm-hmm.
Let me see. We're a bit stuck here. I don't like treetop and AncestorTree. I really don't make it. So one of them is
So why is the consensus that we don't like predecessor tree? And if so, why?
For
'Cause I thought-
ancestor tree.
Yeah.
I kind of like that one, predecessor tree.
I think it's pretty decent. Except it's always a path tree. Except if there are multiple things, it might be a tree. Otherwise, it's a path tree.
Right.
But it's always going to be a tree data structure.
Yeah.
I think
Should-
ancestor
What
tree.
about predecessor path?
Well, because it's a tree. You're going to get a tree data structure out. The predecessor path, I would expect to get a list of nodes, list of elements.
I also briefly thought about source tree, but that's also a
No.
interface for Git, so it's can be confusing.
Predecessor tree. But now, how would I get the list of tree elements out of that?
What do you mean?
I've got predecessor tree. I've got it's a path tree. How do I get the list of elements?
Tree level of that, comma all.
Blah. Not the best thing. I mean, I understand. Tree level, really? No. That's not giving me the elements. It's going to give me a bunch of singleton trees, isn't it?
What do you want? You wanting the data in the tree?
Yes, I want all the data. I want
Then
just
it'd be tree level of level arrow data.
bluff.
Remember that this is a very general sort of thing. It happens that this tree is just a bunch of connected segments without branches, but
No, I
you know,
understand.
when you have branches, you've got traversals.
All right, look, I think predecessor tree is the right name for that, for ancestor
So-
tree.
In the documentation, I commonly use the phrases or the terms ancestors and descendants, and I think those would be equivalent to predecessors and successors. But successors just sounds very strange.
Look, I think ancestor tree just has the problem of genealogical trees, which this isn't.
I think it is.
What do other people think about this? I just think it every time I think about it, it gets confusing. Whereas
This is the
predecessor
function you'll
tree-
type in things like ancestor tree of tree, comma, tree relative, uncles.
Yeah, I mean, I think it is the ancestors, right? I mean,
Right.
if you think it's not just relatives, it is specifically the ancestors.
All right. Okay, well, what about treetop then?
It's the treetop is the leaves. I think treetop is very confusing.
Yeah, I agree with that.
Well, then that will be root tree, potentially. Tree starting at the root
Tree
and going up
trunk.
to. It's not the trunk. It's not the trunk. I mean, look at this.
What
thing.
is
It's not
it?
the trunk.
It's the trunk and the branches. It's everything but the leaves.
Whoa. Trunk and branches is not trunk. I mean, I'm looking at a tree out of a window
it's
here.
everything but the leaves, right?
Well,
That's what it
everything but a
is.
certain level of.
What does trunk
Yeah.
mean to you, Stephen?
It means the main single.
So like in the top picture where you have a part where there's no branching for a while and then branching starts.
Well, there's the trunk, and I mean, I don't know. I don't know which this tree is not a very chunky tree. I mean, a botanical tree is more. Obviously has a trunk and branch.
I feel like when a tree branches, I'm looking at a tree right now that has two trunks. So I don't know, but
Most trees have one trunk in the first approximation. I was literally just going through the live stream about the section of NKS about these things.
I think tree initial might work.
You said initial tree?
Either that or tree initial. I'm not actually sure which is the better order.
I still don't understand why you guys so hate root tree. Because it's the root of this tree. It's the root area.
It's a root of the tree.
What's that?
It's just an arbitrary tree sharing the same root as the original tree.
No, I know, but it's the root region of the tree. Unlike some of these other
I feel like that would be like having, I mean, two problems. The first is that we might already have, but like we can imagine having a function called tree root, which gives you the actual root.
Well, so
and then,
I think tree data is basically that function. Like if you say tree data of a tree, it gives you the data at the root of the tree.
No, that's not the same
so
thing.
actually, wait, how about maybe one solution would be to have, okay, maybe here's one way in which root tree or tree root could actually work. Would be if we had a function tree root, you give it a tree and it returns the root. And then optionally, you can give it some, second arguments where it gives you the neighborhood of the root.
Yeah, well, right.
But the function's first usage though is tree root. It doesn't give you a tree; it gives you the root.
Well,
okay,
so the problem is that we don't have a representation for nodes. We
wait a sec. We have a perfect good. If root tree returns a tree, it just happens to be a singleton tree that is just the root.
I see.
I can just fill the leaves with null or an empty list or whatever.
Yeah, well, that's what we
tree with an empty
standardly do.
list.
Right.
I like that.
And then the second argument tells you how many levels it is. And most of the time, you would end up with, in other words,
default would be 0, but you could say 2.
Yes. Yes.
I'm sorry, I've gotten lost. What is the current proposal?
Okay, root tree of 2 arguments returns exactly what we have here for, with the n as the second argument. Root tree of 1 argument returns the same thing with n equals 0. In other words, it returns the singleton top element, but it returns it as a tree, not just its payload.
Now, but one question is, I would argue maybe it should be called tree root because the framing could be that this is a function that returns the root and it happens to have some extra functionality.
I worry that people will think that that means it returns the payload of the root.
I think we should just document this in comparison with tree data so they know to use tree data for that.
Yeah, I know, but I think if it's root tree, it makes it clear on its name that it is returning a tree.
Well, in some sense, the root tree, to me, suggests that you're talking about the whole tree, the tree itself.
Why?
Instead of just the root of the tree. Because it's the tree that's at the root.
Yeah, like I would imagine root tree would be a function. If we had forests, root tree would be the function when you give it the root and it gives you the tree under it.
And by the way, do we effectively have forests? Are lists of trees effectively forests?
Yeah.
Are those actually supported by functions though, as forests, like by tree functions?
We don't currently have any tree functions that need lists of trees.
No, but do they take lists
on trees?
Are they
themselves.
capable of taking lists of trees?
I mean,
I would say we assume that forests are connected by some node and then converted into a single tree.
I see. I unfortunately have to leave, even though we've got a lot of very interesting and juicy things to discuss here. Perhaps we can have a part 2 sooner rather than later. There's a bunch of important things here. Drat. I really wanted to. We got to continue with this particular thing. Yeah. So let's see whether we can get this scheduled soon.
Okay. Yeah, we'll talk to scheduling.
Okay. Thanks, guys. Sorry, I have to run. Actually, hold on 1 second. Let me just determine. Yeah, I think okay. All right.